Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
This one question lost more marks than any other on last year's higher paper, not because it was hard, but because students treated a rounded number as exact and didn't show the bounds. Imagine finishing an answer and watching 2 marks vanish because your presentation didn't show the inequality. Painful, right? Today we'll fix that with a simple, repeatable method that secures method marks even if your arithmetic slips.
That sounds useful already. So what's the key idea? Are bounds just a bit more and a bit less?
Exactly, but we need to be precise. The concept of upper and lower bounds captures all the possible exact values that a rounded number could represent, but not including 3.465. We write that as 3.455 less than or equal to x less than 3.465. Saying about 3.46 isn't enough. Write the inequality. Let's break that down step by step and look at a few examples so this becomes second nature.
First rule, to dp means the step size is 1 in the last decimal place. For 2 decimal places, that step is 0.01. Half a step either side is 0.005. So take the rounded value and subtract half a step for the lower bound, add half a step for the upper bound. And remember, the upper bound is exclusive. Example, 3.46 to 2dp. So lower, 3.46 minus 0.005 is 3.455. Upper, 3.46 plus 0.005 is 3.465. So 3.455 is less than or equal to x, less than or equal to 3.465.
Okay, lower inclusive, upper exclusive. Why exclusive on the top?
Great question. We make the top exclusive because if x were exactly 3.465, it would round to 3.47, not 3.46. The lower bound is inclusive because a value exactly at 3.455 does still round up to 3.46. Keep that inclusive-exclusive rule in your head. Lower inclusive, upper exclusive for rounding. Now, significant figures. The rule is the same idea, but you measure the step where the last significant digit sits. Take 4.56 to 3 significant figures. The last significant digit is the thousandths place relative to that number. The half step is 0.005. So lower, 4.555, less than or equal to x, less than or equal to 4.565. If the number were 0.004567, rounded to 3 significant figures, you find the third significant digit and apply the half step there. It works the same way. It's just you have to count significant digits from the first non-zero.
Could you give a quick measurement example, like in a practical question?
Sure. Suppose a recorded length is 12.3 centimeters to 1 dp. Then the step is 0.1, half step 0.05, so 12.25 is less than or equal to L, less than 12.35. If you're asked to use bounds in further working, always substitute those inequalities, not the rounded numbers. That keeps method marks safe, even when calculators or arithmetic slip up.
Right, that's the concept. Now let's switch to exam technique. How examiners award marks, and what to write to capture them.
Many bounds questions are 3-mark questions. Typical breakdown: M1 for writing the correct inequality for at least one measurement, M1 for applying the method correctly, for example, multiplying the bounds through or substituting inequalities into a formula, and A1 for a correct final statement or numerical value, if required. So even if your final arithmetic is a little off, you can still get 2 method marks by showing the setup clearly.
So showing those inequalities is half the battle, even before you touch the calculator.
Exactly. Write the bounds. Label them. For example, write length L, 12.25, less than or equal to L, less than 12.35, and width W, 3.455,
less than or equal to W less than 3.465. Then show the method. For instance, L times W lower bound equals 12.25 times 3.455, upper bound equals 12.35 times 3.465. If the paper wants the final bounds, give them as an inequality or interval and state which is inclusive or exclusive. Even if the multiplication gives slightly wrong decimal places, the M marks remain.
A quick tip about notation. Use less than and less than, or write X is at least this but less than this. Examiners just need to see you've captured the range. If you use interval notation, write it correctly as 3.455, 3.465. Either is fine, as long as it's clear.
Now, for your 10-second quick win. A routine that turns this into exam muscle memory.
Quick win routine. 1. Write the rounded value. 2. Write the half step and compute lower and upper. 3. Show the inequality. 4. Test the midpoint if you have time. Example in 10 seconds. Number 3.46 to 2dp. Write 3.46, half step 0.005. So 3.455 less than or equal to x less than or equal to 3.465. Midpoint is 3.46. Test it mentally to check you didn't slip a decimal. That's your 10-second safety check. Do this every time a question gives a rounded number.
Testing the midpoint sounds smart. It catches silly slip-ups quickly. Can we see this applied to a short past paper style question?
Absolutely. Practice question. A rectangle has length 12.3 centimetres to 1 decimal place and width 3.46 centimetres to 2 decimal places. Work out the upper and lower bounds for the area. Step 1. Write bounds for L and W. L, 12.25 less than or equal to L less than 12.35. W, 3.455 less than or equal to W less than 3.465. That's M1, you've defined the ranges. Step 2, for the area A equals L times W, the smallest possible area is the product of the two lower bounds and the largest possible area is the product of the two upper bounds. Show both multiplications, that's M1 for method. Step 3, evaluate the two products and state A in interval form, that's A1 for the final answer.
Concretely, lower area equals 12.25 times 3.455 equals 42.31875. Upper area equals 12.35 times 3.465 equals 42.806. So you would quote 42.319 less than or equal to A less than or equal to 42.806, rounding the bounds appropriately if the question asks. Note, even if your calculator gives slightly different final decimals, you still keep M1 and M1 because you showed the inequalities and the method. Always label which bound is which as you write them. Examiners love that clarity.
Nice. So show working clearly, label it, and the marks are there.
Before we finish, 3 common mistakes and exactly how to avoid them. Number 1, mixing up decimal places and significant figures. Fix. Pause and say aloud DP or SF before you start. Number 2, forgetting to show inequalities. Fix. Make it a rule. Always write the inequality line as your first step. Number 3, truncation versus rounding. Truncation chops off digits. Rounding uses half-step rules. If a question says to 2dp, it's rounding, unless it explicitly says truncated or rounded down. If you ever suspect truncation, write that explicitly and justify it.
A very short memory line to say out loud when you start. Half step, write bounds, show method, label answers. If you make that a habit, you will stop losing those avoidable marks. Let that sink in. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam.